What's up, AP Bio Penguins? So let's talk about all the graphs that are going to be on the AP Bio exam. One of the questions that's always asked of me is, what kind of graph am I going to make? So let's talk about the different types of graphs, and let's talk about how to know which graph we're going to make, and then what those graphs look like.
So for this data, we've been given the 6 different strains of corn, as well as we've given the number of double-stranded breaks and the average number of crossovers. So this means to me that it's going to be some type of scatter plot. They've already labeled the axes for us, number of double-stranded breaks, as well as average number of crossovers. So I know it's on my X and my Y. And so I'm going to plot each of these individual points. So at 710, 19.5, I'll put that data point. And so that's what they're going to end up doing, is that they plot their data points, that 19.5 with 710, and then they're going to label each individual point since this is a scatter plot, okay? And then here's another example of how you might see it. So the student made a key in which they use different symbols for the different ones. So you don't actually have to label each individual one like on the graph, but you could have just made like a key and made different symbols. So for this one, we've been given categorical data. You have 6 different species. And you have 2 different treatment groups, the mitochondria at normal and the mitochondria at elevated levels of carbon dioxide. Okay, so this is going to be a bar graph, and so you'll put your species on your x-axis. You'll have the number of mitochondria on your y-axis. And so the reason I know it's going to be a bar graph is because it's categorical data. And then so you'll put your bar being the height for the mean. So here we go up to 1.0, and then you'll put your error bar going 0.1 up and 0.1 down. And so this student chose to make a key on the side, which was great. And so they just put the 2 for species 1 together, 2 for species 2, and so on and so forth, so they could then do the comparison between the normal and the elevated levels. So this one, we have different times. So it's a linear scale and linear data. So although I have species A and species B, and I'm looking at kind of how those were grown together, grown separately, I'm actually going to do a line graph for this one. And so they actually were really nice, and they gave you kind of 2 of them already graphed, so you had to put it on there. And so on this graph, you would have figured out where the endpoint was to be able to figure out, well, this is 700, and that's 1400. So you'd be able to then graph those points to put them onto your graph. So I don't know if you're going to have to actually graph a box and whisker, but this is a box and whisker plot. And so you may have not seen it before, but what you're seeing with each of these is you're looking at 100% of the data, where the line that's in the middle is going to be your median, and you've got 50% of the data above, 50% of the data below. And so from the top of the box to the top of your line is 25% of your data. From the median to the top of the box is 25%. From the median to the bottom of the box is 25%. And then from the bottom of the box to the bottom of this line, that's the other 25% of your data. And so you might have to use that to analyze multiple choice or for your response question.
So hope this was helpful. Remember, AP Bio Penguins, just to satisfy y'all.